Hello, hi everyone. Today we discuss the topic is EMF equation. EMF equation of DC generator. EMF equation of DC generator. So before we discuss the EMF equation of DC generator, we need to some basic compounds. So what are the basic compounds? So in previous classes we have studied in armature reaction. So armature reaction, we need to some armature reaction and construction part. So armature reaction and construction part, what we learn, the construction part basically uh, stator part and rotor part. In stator part consisting of number of poles, P is equal to number of poles. And similarly in armature side there is the stator side, and coming to the rotor side we are connected to the number of conductors, so that is indicated to Z is equal to number of armature conductors. And after armature, the armature is always rotating device. So here we are taken to the rotating device, that will be taken as N. N is equal to speed of the armature. Speed of the armature. In we are taken to the RPM, revolutions per minute. So next we go to the in stator side. Stator side, we need to armature reaction. We taken from the armature reaction. Armature reaction, what happened? We are consisting of number of poles. So they are the poles. Each pole consisting of number of conductors. So this conductor which creates some flux. So here flux is some flux. That is nothing but the pi. We are taken to the flux. We are taken to the pi. That is pi is nothing but flux per each pole. Flux per pole. How much flux will be created on in this pole? Similarly, how much flux will be created on the remaining pole? So that we are taken to the flux per pole. So next, first one is the stator side, where consisting of poles and armature conductors, and speed, flux per pole. Again, another one point in armature winding. Armature winding is consisting of north pole and south pole, different type of the number of conductors will be there. So at the same case, we are consisting of A, parallel paths. Parallel paths. Parallel paths in the armature winding. So what are the parallel paths? So parallel paths, A is equal to P. That is for lap winding. Lap winding. And A is equal to 2. That is for wave winding. The parallel paths of lap winding and wave winding. So from these are simply మనం వంట చేసే ముందు రా మెటీరియల్స్ అన్ని ఉప్పు కారం పసుపు అంతేనా. సో దెన్ ఆఫ్టర్ మనం ఏం చేసుకోవాలి, ఒక స్పైసీని రెడీ చేసుకోవాలి. దట్ ఈస్ స్పైసీ ఈజ్ నథింగ్ బట్ ఈజీ జనరేటెడ్ ఈఎంఎఫ్. జనరేటెడ్ ఈఎంఎఫ్ we can find out the generated EMF. These are the all things are primary. So ఏదైనా ఒక స్పైసీ రెడీ చేసుకుంటున్నాం, ఆ స్పైసీ ఏంటంటే జనరేటెడ్ ఈఎంఎఫ్. దానికి కావాల్సిన ఉప్పు కారాలు ఇవి. సో దీంట్లో మనం ఏం చేసుకున్నాం, ఇవి ఎక్కడి నుంచి వచ్చినాయి, కన్స్ట్రక్షన్ నుంచి పోల్స్ తీసుకుంటున్నా, అండ్ ఇవన్నీ కన్స్ట్రక్షన్ పార్ట్. ఇది మాత్రం ఫ్లక్స్ ఇస్ ద ఆర్మేచర్ రియాక్షన్. ఆర్మేచర్ రియాక్షన్ నుంచి ఫ్లక్స్ వస్తుంది. సో నౌ let us we start the cooking. So from the here first part is according to Faraday's laws. Faraday's laws. What is the Faraday's laws? Whenever a conductor cuts the magnetic field, the EMF will be induced into the conductor. That is the Faraday's first law. So here we are taking to the first flux cut. Flux cut by one conductor per one revolution. One revolution. Armature consisting of number of conductors, but we are assuming we are taken only one conductor. The armature is always rotating, so but we are taken up to only one revolution. One revolution, one conductor. So how much flux will be cutting? So there is a small amount of flux will be cutting. So that small amount of flux is always taken to the d pi. Everything small thing, when we are needed to the small thing, that will be indicated with the డిఫరెన్షియేషన్, ఎక్కడైతే నీకు కంప్లీట్ ఏరియా కావాలనుకుంటారో అక్కడ ఏం చేసుకుంటున్నాం మనం, ఇంటిగ్రేషన్స్ వాడతాం. సో దర్ ఇస్ అ mathematical equation. So we need to the small amount of flux, that is nothing but the rate of change of flux, that is the d pi. So here what is the d pi? D pi is completely one revolution. So complete one revolution is we are taken to the some poles. So that is a poles into total flux, that is pi into flux. Pi into flux. So we are taken to the d pi, that is a Webers. Units is Webers. Okay. So first flux cut by conductor. Similarly, next it is a completely taken to the one revolution. So how much time will be taken for the one revolution? That is the time taken for one revolution. One revolution time taking, that is the dt. So 60 by n in seconds. We are taken to the seconds. Okay. So they are the flux cut by conductor, flux cut by one conductor for one revolution, and time taken for the one revolution. So now coming to the Faraday's law. Whatever the Faraday's law? Faraday's law is equal to, whenever a conductor cuts the magnetic field, the EMF will be induced into the conductor. That is nothing but the E is equal to n d pi by dt. So what is this? These are according to from Faraday's law. From the Faraday's law. Here n is equal to number of conductors, but we are taken to the how many conductors? Only one conductors. That is, we are taken to the Eg. Eg is equal to n is equal to 1, and d pi is equal to pi into p. Again, what is the dt? Dt is equal to 60 by n. So we are taken to the denominator goes to numerator. So Eg is equal to pi p n by 60. So this is EMF for conductor. Only how many conductors will taken? Only one conductor will be taken, that is EMF per conductor. EMF per conductor. But we need to complete EMF. So this EMF only one conductor, but we need to total number of conductors. We are taken to how many conductors? Z conductors are armature having Z number of conductors. At the same case, armature having some parallel paths. So let us total EG, induced EMF. EG is nothing but the induced EMF. Total induced EMF is nothing but each EMF per conductor. Total EMF is equal to EMF per conductor into total number of armature conductors, total number of armature conductors by parallel paths. Let us say considering total induced EMF. That is, total induced EMF Eg is equal to induced EMF for conductor is equal to pi p n by 60 into total number of armature conductor we are taken to the Z, and what is the total parallel paths? Parallel paths is equal to, we are consisting of A. So this is the finalized equation for induced EMF for generator. These are the induced EMF for generator. Similarly, motor. In induced EMF is called for generator. Similarly, motor, it is called as back EMF. Here we are calling as back EMF pi p n 60 into Z by A. It is a motor. In terms of motor, it is called as back EMF. In terms of generator, it is called as generating EMF. So this is a EMF equation for generator. So some little bit of calculations. So what is the induced EMF? Eg is equal to pi p n 60 into Z by A. Okay, here P is the constant. Based on construction, P is the constant, and based on construction, Z is the constant. Number of armature conductors also constant, and parallel paths also constant. So these are the constant terminals. So what are the remaining terminals? Pi and Z. These are the variables. These are variable devices because of, so in DC machine as a generator or motor, the speed will be variable. So the speed will be variable. Again, flux. We need to, already we discussed the armature reaction. Armature reaction, what happened? Magnetization effect to demagnetization effect to, and that the case of what happened, the flux will be changes. So for example, at load condition and no load condition, what happened? Load condition, the MNA is always in axis with the interpolar axis. When full load condition, what happened? MNE is shifted to the some angle, so that the condition flux will be varying. So finally, what happened? The flux is changes and speed will be changes. These two are in variable terminals. Remaining these three are the constant terms. So generally, and Eg is directly proportional to pi into n. So induced EMF is always depends upon the flux into speed. So again, we can find out the speed. Speed is directly proportional to the induced EMF for flux. But this flux is some two case. One is saturation case, unsaturation case. When saturation case, the flux remains constant. When saturation case, flux will be constant. Flux is constant, saturation case. So that case of speed is directly proportional here. At the case, speed is directly proportional to only induced EMF, EG. EG only. So when it is an unsaturation case is nothing but flux is does not constant, the flux is variable. The flux is variable. That case of the speed is depends on both Eg and pi. So it is depends on Eg and pi. But when it is a constant here, saturation condition, speed is depends on only induced EMF. So this is the class for EMF equation for DC generator. Also it is also back EMF for DC motor. Thank you.